Hi, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to continue with the lecture series on the design and analysis of algorithms. Let's discuss in this video the definition of, let us discuss the definition of an algorithm. So what is an algorithm? It is a finite set of steps to be followed in a particular problem. If you want to define an algorithm in the simplest way, then algorithm is actually a finite number of steps to solve a particular problem. Let's say I have a problem of sum of two numbers. Now I can write sum of two numbers in C program also. I can write its code in multiple languages like Java or Python. So here actually the problem is I have to write here in a layman language. I have to write a blueprint rather than going into a particular programming language. I want to write what is going to happen behind the scene. Like I wrote how in the step 1 it is read A, step 2 it is read B, step 3 sum of A plus B, and finally it is to print. So actually here my problem is being solved in 4 steps. What can I do further in C language or any programming languages? We can convert it and execute it. So here the basic definition of algorithm is it should be written in a finite number of steps. Remember the characteristics of algorithm. First it should be containing the finite number of steps. What work we have to do is finite means the number of instructions should also be finite. And if I talk about an instruction, then in executing the instruction finite time should be taken. Means let's say if I write, for example, if I write while 1, let's say int a is equal to 1, while of 1, and inside that a is equal to a plus 1. Now here what I have is, if I write while 1 here, that is while 1, then obviously what will happen, the statement will execute infinite number of times, that is a is equal to a plus 1. It executes infinite number of times. So whenever you are writing any program or any algorithm of this type, then where it is going to be infinite. So you don't have to write any algorithm of this type. It should contain only finite number of instruction, and each instruction to take finite time to get executed. If I talk about the second one, the second characteristic, that should not be any ambiguity. Ambiguity means, let's say you wrote instruction multiple times. So or let's say you wrote the symbol wrong. Instead of plus, if you are writing any other symbol, instead of plus, if you are writing any other symbol, then you don't have to write symbol of this type. It should contain the relevant symbols. It should contain the unambiguous instructions. Then we have analysis. So whenever you talk about algorithm, then we will talk about analysis. What is analysis? It is a process of comparing two algorithms. Means I have multiple algorithms. Like if I talk about searching, then I have binary search and linear search. Let's talk about sorting. I have heap sort, quick sort, merge sort, radix sort, counting sort. So there are multiple sorting algorithms. If I want to compare them, which one is better, then I need some constraint for that. I need some parameter. That parameter is time, space, number of registers, network bandwidth, means how many components are being used here. But out of all these parameters, the most used is time and space complexity. Means you are comparing two algorithms based on time and space they are using. So analysis is the most important part of the algorithm. That's how we are working out time complexity and space complexity. Now we do analysis in two ways. Now we do analysis in either two ways. Priority means analysis before execution, and posterior means analysis after execution. So whenever we do analysis before execution, then it is independent. So we remember that when it is independent of a particular hardware. Let's say if we write code here main, and I have int a, int b. Okay, if I have write a code int a and b, and let's say I have taken some one here, I have done scanf here, values of a and b. I have done sum as plus b and printf the value of sum, or you can say whatever that thing. I have written simple values here, the number of lines. So when you are executing this program, now in executing it, definitely it will take some time. Now when you execute it, then after executing means posterior analysis. So you got the output but you got time, let's say 0.4 second. Now whenever there will be a posterior analysis, it will give you a fixed amount of time, and that time is 0.4 seconds. But if I change this whole program, let's say if I change my hardware, then it takes, let's say it is from Pentium 4 to i3 or i7, so the time will be 0.3, 0.2, 0.1, means it is decreasing.